Okay, now this is the third part, the last part of supplementing, at least for this stage in the game, of lesson 1.4, Universal Dwelling, and helping students understand the heat concepts involved in that. So we're on the last standard addressed at this point, which is 3.3. As there's an increase in temperature, that means we have faster molecular motion, the molecules moving faster, and that means there's an increase in average kinetic energy of those molecules. And I have this kinetic term, a different color, to bring that to your attention. Another word that you definitely want to put on your word wall at this point, because they'll be using this term again later, as you discuss, motion, kinematics, kinetic energy that's in there. So, you want to define this term for them. Just basically kinetic, define it as moving. So this is energy of movement. Nice little picture here I found online, but low temperature versus high temperature, showing the difference in movement. But there's a much better way to show this as well, much more dynamic way, and I'm going to go into that. First, these are some great science videos. They have more than just heat videos on there, but they're old and quirky, and that's probably maybe some of the reasons why I like them. But they provide a lot of great information. It's called Eureka Science Videos. Here's the URL there, and I'm just gonna kind of show you real briefly what I'm talking about here. We go there to that, and you could just type in the number of the video. For example, these have a lot: evaporation, condensation, expansion, contraction, molecules in the solid, molecules in the liquid. This is all part of standard 3.3. The standard talks a bit about, solids and liquids, cooling process, warming process, evaporation, condensation. So it's all in here. Great way. They're very short videos. For example, I'll show you 19 just real quick. You type it in. Let me put in video 19 and hit enter here. I'm just going to fast forward a little bit.
Hot molecules take up more space than cold molecules. It's as if a lot of angry wasps were buzzing about inside the balloon. The hotter they become, the faster they buzz. And the further out they push the sides of the balloon.
Cool. So you see that little illustration here of the balloon. There's actually been like MCAS questions that talk a bit about that too. When you leave, a balloon out in the sun, what happens, those sorts of things. So I actually like to follow up here with having a balloon in hot water. And the students get to actually watch the balloon expand in the hot water. They always like that. I happen to be lucky enough to have one of these ball and ring apparatuses where you heat it up and it no longer can fit through the ring. And that kind of helps relate to, some real life applications of the expansion strips on roads, why those are necessary. And the Eureka video, actually, that video I've shown you talks a bit about that as well. So these are really good videos to show at this point. They're very short. They're only a few minutes long. If you want, you could, watch it ahead of time and have a couple questions ready for students on a worksheet and give it to them to fill out. I tend to do that just to make sure they're engaged in the video. But, it does give very brief but very visual and engaging content for students. So I like to show that and then follow up with some in-class demonstrations. And here is one of my favorite ways to show this kinetic molecular energy piece, standard 3.3, is using this PhET simulation. And if you happen to have computer access, you could have students do it themselves. If not, you could show it as a demo in front of class. But it's always better if you could actually get students using computers. If you go to PhET, there's worksheets under. If you go to each simulation, there'll be an area where you can actually for teachers. You click there and there'll be like, worksheets that you could get that are available. So students could to do some work as they go through it. You could browse what they have available. But, this is great to show the students as far as like what happens as you add heat to the motion of molecules. You see how they move faster. You can relate this to that part of the standard talking about, solid, liquid, and gas, what's happening there. So I love this. It's a great way to show what happens to the motion of molecules, relate that to the temperature as a measure of the average kinetic energy. And again, as I mentioned before, that physics classroom has a good supplement text on what temperature really is. So as you watch the last video, I introduced the physics classroom. That gives some more text about, temperature as a measure of the average kinetic energy. So something to keep in mind there. But I'd like to show them this visual. It really brings home that as temperature increases, these molecules are moving faster, and kinetic is the energy of movement. So they're going to have greater average kinetic energy. So something to show with students, or even have them do if you have computers available. And if you check out the MCAS question search on the Weebly or the DOE site, you'll see a ton of questions around this concept of, the average molecular kinetic energy, or the KMT theory of heat. You'll see a lot of questions around that. Not so many questions about, solids and liquids, melting, heating and cooling processes. But every now and then they do throw a question on evaporation or condensation on there. So I do like to have just like a day where I do like an evaporation condensation lab. There's some simple ones, very easy to do, where you just have 2 plastic cups, warm water in there, and put an ice cube on one, and students could see the difference in the amount of condensation between the two. You can use that as a discussion point for why that's happening, and start to teach around evaporation and condensation being, warming, cooling processes, what's occurring there. Or if you have not many classrooms have a gas hookup, unless you're lucky enough to be in a chemistry class. But you could use a hot plate and just a beaker of water, and then a watch glass. Okay, borrow this from your chemistry colleagues, and put some ice in that. And this is a good way to show evaporation, condensation. As the water's heated, obviously evaporates, but as it touches the cool watch glass due to the ice, they'll start to see, condensation build up on that watch glass. So you could begin to talk about why that's occurring, and relate it to warming and cooling processes, and the transfer of heat, of thermal energy involved in these processes. So that's a bit of what I like to do and how I like to supplement for that standard. So as I mentioned, as students build and test their homes, in order for them to get that content knowledge, you're going to have to add a few materials, add a few activities to your lessons. So I hope that these few videos I just showed you give you some ideas. And for further ideas, this was brought to my attention at a recent conference I attended, Share My Lesson. They also have some good resources there, and a lot of Boston teachers have been working on providing lessons for Share My Lessons. So check out what they have as well to find some more ideas about how to supplement and teach some of these heat concepts. So I hope I gave you a few ideas you could use.